Yes, sir.
Or go down to the next level. You can walk along this bench and see the bottom 10 feet or 15 feet of this face pretty easily. That'll be all you need to see. Did you notice that as we came from Verona, the town of Verona, that way, we came uphill? Notice that? Long grade.
Yeah.
Right. At the town of Verona, you are down at the level of the St. Peter sandstone, in the middle of the Ordovician. You've got a handout, I hope?
Yeah.
This one?
Yep. You getting there? Or maybe not.
Looks like this. St. Peter sandstone. Got it? So we came up a long grade. The rocks are completely horizontal. And so if you come up topographically, you must be coming up stratigraphically. And that's what we've done. We've climbed up out of the St. Peter, through the Platteville Formation, through the Decorah Formation, and we're now at the level of the Galena Formation. That's what this wall is right behind us. We are at this point low in the Galena Formation. The Galena Formation is 200 feet thick around this part of the world. It is very difficult to see an entire section of the Galena because our outcrops are rarely 200 feet thick in this part of the world. Normally we see 50 feet or 60 feet or something like that. Only a piece of the whole Galena. There is a big outcrop over on the Mississippi River where the entire Galena is exposed. And the state of Iowa even put up a road sign to commemorate that fact, that the whole thing is there. But around here in southern Wisconsin, you only see bits and pieces of the Galena. The stratigraphers at the Illinois survey many years ago decided that they needed to be able to subdivide the Galena because they wanted to be able to know where they were in the section at some little outcrop like this. And so they developed a series of subdivisions, and I think you have that handout as well. And these are called stratigraphic members. And you can see they're given names: Buckhorn, St. James, Beecher, Eagle Point, Fairplay, so on and so on and so on. Member after member after member after member. They really subdivided it. The people at the Illinois survey are splitters. They want to subdivide because they have that great big basin, the Illinois Basin. Now you guys also are Illinois Basin types, right? Your school sits on rocks in the Illinois Basin. And so the stratigraphy that the Illinois survey put together is similar to the stratigraphy that you would see from the Indiana survey as well. But it's different from up here in Wisconsin because we're not in the basin. We're on the flanks of a cratonic dome here. And instead of having many thousands of feet of sedimentary rocks between us and the basement, we only have about 1,000 feet. The granites are only about 1,000 feet below our feet right here. So all the Cambrian and all the Ordovician rocks are really not very thick at all. Nonetheless, we've adopted, for the most part, the names that the Illinois survey put together for the subdivision of the Galena. The subdivisions are exceedingly subtle. The rock is in fact quite uniform for the whole 200 feet. And so if you look at your strat section and say, okay, show me the Buckhorn and show me the St. James and show me the Beecher and show me the Eagle Point, I'll say what's right here in front of you. That's it. About 15 feet up, you can see some white stuff sticking out of the outcrop. See it right up there? Little nodules of white stuff. That's chert. And that chert defines the base of the Eagle Point member. There isn't any chert in the Beecher, the St. James, or the Buckhorn. But you notice that the rest of the rock looks just the same. And that's the case for the entire Galena Formation, all 200 feet of it. If I take you to a typical Galena outcrop, you're going to be able to say, oh, that's the Galena, but to decide where you are within it is, in fact, somewhat difficult. You really have to spend time with this Illinois subdivision and learn it carefully. The rocks, the member boundaries don't just leap out at you. So I've given you this thing just really for your information. We're not going to be doing real stratigraphy here because it's too subtle and because we don't want to climb that surface. I'm going to show you some sedimentologic features, but that's the stratigraphic background. Okay, questions?
Some of them don't know what a dolomite is.
All right.
So
this will be a great we'll talk about that.
Well, how did they end up dividing these? How did they choose which one?
You can see on the log that the Eagle Point member, for example, has chert in it, and the overlying and underlying rock didn't. And you get up here into the Mortimer member and the Rivoli member. They also have some chert, but they have a little more shale than the underlying Eagle Point. And so it's really subtle things like that that they utilize to do their stratigraphy. You can trace the Illinois subdivisions into Wisconsin pretty easily, but you really have to know what you're doing to be able to see it.
So those members, I mean, they do have a geographic extent.
Oh yeah,
really, yeah.
They definitely do. Now, the Galena Formation as a unit extends from here up into Minnesota, over into Iowa, as far as Nebraska, all through the Illinois Basin, and over into coeval units in Ohio. In other words, it's an exceedingly widespread unit, and it maintains its more or less 200-foot thickness throughout that extent. This is a good example of what's called layer cake stratigraphy. Flat-lying layers that were accumulating more or less simultaneously over a very broad area.
Does it maintain the same name over all those areas?
Over most of that. It started changing its name in Ohio. But it goes all through the Illinois Basin with the same Galena name. It goes across Iowa with the same name up in Minnesota as well.
Those Buckeyes don't know much about naming things, so they just kind of change. That's what it is, you know.
There's, I think what happened here, this was a limestone when it was deposited. I think this thing was deposited at a time of a fairly substantial sea level high stand when the whole central part of the United States was underwater to a significant degree. I think it was tens of meters at least, maybe 100 meters deep. We don't know for sure. But the fact that the thing is so widespread, is so uniform in terms of its lithology, is so consistent in terms of its thickness, argues to me that we're talking about a depositional drowned shelf that was very, very, very wide. We are sure that this is a marine rock. There are marine fossils in it. I will show you a few. It was deposited as a limestone. Most of the sedimentary grains when they were deposited were a kind of carbonate mud, fine-grained carbonate. You don't see big intraclasts, you don't see big chunks, you don't see a lot of sedimentary grains like quartz in this formation at all. It's a very pure was originally calcium carbonate, and pretty fine grain. But, and this is the kicker, between the time it was deposited and now, it underwent a chemical transformation from limestone to dolomite. Dolomite is a carbonate mineral. It's a calcium magnesium carbonate. A pure dolomite has a calcium ion and a magnesium ion 50-50 with the carbonates. So half magnesium, half calcium. That involves a recrystallization. The mineral dolomite crystallizes in a different manner than calcite does. And so the dolomitization process, which occurred deep underground as it was being flooded with some kind of basinal fluids, that mineralogic change was a recrystallization. And in the process of recrystallizing, the texture of the original rock was badly changed, and the fossils were dissolved and rendered hard to see. And it's just a tragedy. I hate dolomite. I'm a sedimentologist and a paleontologist, and things that tear up fossils I just despise. So dolomite is not my favorite rock. If you get a piece of this stuff, and we'll look at it more in just a second. If you get a piece of this stuff, excuse me, and look at it with your hand lens, you can see the dolomite crystals, little rhomboid crystals. They're more or less on the scale of from 1/10 of a millimeter to 1/2 millimeter, or maybe 1 millimeter or so. Not real big though, but big enough to see with your hand lens. Maybe we should look at that right now.
Yeah.
Okay. Get a piece of this stuff and see if you can see the crystal.